Welcome back to AZ Automotives Reviews, the channel where engineering marvels meet storytelling. Today, we dive into a true giant of human innovation, a machine that doesn't just sit on land or roll on wheels but floats on water while lifting what seems impossible to move. We are talking about the floating crane, a symbol of strength, precision, and sheer mechanical dominance. When you think of cranes, the first image that comes to mind is often the tall skeletal structures on city skylines, slowly piecing together skyscrapers. But floating cranes exist in another world altogether. They combine the stability of a ship with the power of an industrial lifting machine, creating a hybrid that is essential for heavy-duty maritime construction, salvage operations, offshore engineering, and even in some of the most complex shipbuilding tasks on Earth. This isn't just a crane, it's an ocean titan. Let's begin with the story of why floating cranes came into existence. On land, cranes revolutionized how humans built cities, but as industries moved offshore, constructing massive ports, bridges, and oil rigs, the challenge arose: how do you lift thousands of tons where no land exists? That's when the concept of mounting cranes onto barges and ships became a reality. These floating cranes are not ordinary vessels. They are purpose-built or modified to maintain stability while lifting unimaginable weights, sometimes over 10,000 tons in a single operation. The engineering brilliance lies in the balance. Imagine a structure so tall and heavy, mounted on a platform that floats on moving water. One wrong calculation, and the entire vessel could tilt, capsize, or even break apart under stress. That's why floating cranes are masterpieces of naval architecture and mechanical design. Their hulls are often broader than traditional ships, spreading out the weight and offering stability, while advanced ballast systems compensate for the shifting loads during operations. Now, let's talk about sheer power. Some of the largest floating cranes in the world, like the SSCV Sleipnir or the Asian Hercules series, boast lifting capacities measured not in hundreds of tons, but in thousands, even tens of thousands. To put that into perspective, imagine lifting an entire skyscraper, or multiple Boeing 747s, at once. That's the level of power we are dealing with. And yet, these machines do so with remarkable precision. A floating crane can place sections of bridges, oil rigs, or even warships into position with accuracy measured down to centimeters, even while floating on moving water. Power like this requires equally powerful engines and hydraulics. Many floating cranes are powered by diesel-electric systems that deliver constant torque to massive winches and hoists. The cables themselves, wound from ultra-strong steel, are thicker than a human arm, and their length can stretch hundreds of meters. Every movement is calculated, monitored, and controlled to avoid catastrophic failure. The crane's operator sits in a cabin high above, surrounded by an array of sensors, computers, and control levers, making split-second decisions while working in tandem with the crew on deck. It's a perfect dance between man, machine, and water. One of the most fascinating aspects of floating cranes is their versatility. They can be used for shipbuilding, lifting entire prefabricated ship sections into place. In bridge construction, floating cranes carry out the task of positioning huge concrete segments that would be impossible to transport over land. During salvage operations, they rise as heroes of the sea, lifting sunken vessels, removing wrecks, and even recovering valuable cargo from the ocean floor. Think of some of the most iconic salvage operations in history. Floating cranes played a crucial role in recovering submarines, capsized ships, and even sections of offshore oil platforms that were destroyed by storms. Without them, many of these maritime challenges would remain unsolved. Their importance goes beyond construction. They are instruments of rescue, recovery, and rebuilding. But there's also a fascinating competitive edge among nations and companies to build the largest and most capable floating cranes. Just as car manufacturers compete for horsepower and speed, shipyards and crane companies compete for lifting capacity and precision. For example, the SSCV Sleipnir, built by Hirama Marine Contractors, holds the record for the largest semi-submersible crane vessel in the world, capable of lifting 20,000 metric tons. That's nearly double the weight of the Eiffel Tower. And it doesn't stop at just size. Technology integration has become equally impressive. Modern floating cranes are equipped with dynamic positioning systems. These systems use GPS, thrusters, and advanced sensors to keep the vessel steady at sea, even without anchors. Imagine trying to hold a ship in the same spot while waves, tides, and winds are constantly pushing against it. With dynamic positioning, the crane can maintain its place with pinpoint accuracy, ensuring every lift is safe and precise. Another remarkable aspect is how these giants are designed to travel across oceans. Many floating cranes are self-propelled, meaning they can move from one project site to another without needing to be towed. Others, especially the largest ones, rely on tugboats for relocation. Watching one of these colossal cranes being escorted through narrow straits or into shipyards is a spectacle in itself, a moving city of steel and power gliding across the waves. From a viewer's perspective, it's easy to be mesmerized by the visuals, but the human element behind floating cranes is equally fascinating. Operating one isn't just about pressing buttons, it's about years of experience, precision, and teamwork. Crews train extensively to synchronize movements, communicate effectively, and anticipate changes in sea conditions. Every lift is rehearsed, every possibility accounted for, because the stakes are so high. One miscalculation could mean millions of dollars in damages or worse, human lives at risk. This brings us to safety, one of the most crucial aspects of floating crane operations. Redundant systems are built into every part of these machines. Multiple winches, backup power systems, and real-time monitoring sensors ensure that operations continue smoothly even in case of partial failures. Safety officers and engineers are always on standby, watching every move, every load chart, and every weather forecast. These precautions make floating cranes not just powerful, but reliable. There's also an environmental aspect to consider. With stricter global regulations, modern floating cranes are increasingly designed with greener technologies. Fuel-efficient engines, advanced emission systems, and hybrid propulsion units are being adopted to reduce their environmental footprint. Some newer models even integrate artificial intelligence for real-time monitoring of energy consumption and efficiency. This is the future of heavy lifting at sea, where sustainability meets power. Now, let's take a step back and appreciate the spectacle. Picture yourself standing on a harbor, watching a floating crane maneuver into position. Its immense boom towers over the skyline, cables dangling like steel webs. The ship beneath it dwarfs tugboats and barges, looking less like a vessel and more like a moving island. When the lift begins, the tension in the air is palpable. You hear the groan of winches, the rumble of engines, and then slowly, almost majestically, a massive load rises from the water or the dock. It's a performance of raw strength, orchestrated with precision, and it never fails to inspire awe. For those of us who admire machines not just for their size but for their purpose, floating cranes represent something profound. They embody the human drive to conquer challenges, to push the limits of what is possible. They are built not just to lift, but to solve problems that no other machine can. And in that sense, they are the unsung heroes of modern engineering. In the world of automobiles, we often celebrate supercars for their speed, luxury, and performance. In the maritime world, floating cranes are the equivalent, except instead of racing down highways, they redefine skylines and reshape oceans. They may not be glamorous in the traditional sense, but their beauty lies in their purpose, their power, and their sheer presence. At AZ Automotives Reviews, we don't just look at machines, we explore the story they tell. And the story of floating cranes is one of ambition, innovation, and resilience. They remind us that when faced with challenges as vast as the sea itself, humanity responds with ingenuity, courage, and steel. So the next time you see a photo or video of one of these giants, remember that behind its steel frame lies decades of engineering, thousands of human hours, and the vision to achieve what once seemed impossible. Floating cranes are not just machines, they are milestones in our journey of progress. If you enjoyed this deep dive into the fascinating world of floating cranes, make sure to stay connected with AZ Automotives Reviews for more explorations of the extraordinary machines that shape our world.